We have been discussing about the cost sheet. It is the final output of the costing department. It shows the cost of production per unit of the end product. In a service industry, the cost sheet shows the cost of delivering the services. Let us do one comprehensive exercise to understand the preparation of a cost sheet. This exercise is a manufacturing industry. We will do one more exercise later on service industry. We have a company called Autocomp Limited. This company manufactures 3 automobile components. The products are complex and require different materials, components and process. The 3 end products are named P101, 102, 103. The company uses 5 materials and components. The materials and components are named R101 to R105. The material go through the 5 production facilities. Of these 5 facilities, 3 are machine shops. Machine shops are numbered as M101 to M103. After processing in the machine shop, the material moves to assembly shops for final assembly. The final product comes out of assembly shop A101 and A102. During a period, Autocomp manufactured 10,000 units of P101, 15,000 units of a P102, 60,000 units of a P103. There are 2 complexities in manufacturing. The material and production shop requirement vary from product to product. The capacity available in the production shop is more than the requirement. We need to address this underutilization when we cost the product. The material requirement for different products and cost per unit of material are available to us. Of the 5 material, P101 requires 4 material, 102 requires only 2 material and 103 requires 3 material. The quantity requirements are also different. The cost of material is shown in the last column of the table. Now we can compute the material cost for each of the product by multiplying the material requirement and cost per unit. If we sum up the cost, you get material cost per unit of 101, 102, 103. Total material cost per unit of a product P101 is 1840. For other 2 products, the material cost is 1120 and 1760. The material cost for the month can be computed by multiplying the cost per unit and output quantity. Total material costs for each of these products are 18.4 million for P101, 16.8 million for P102, 105.6 million for P103. The product demand on machine shop is different. We have standard time required for process of product under different machine shops. For example, machine center 101 can process the first product at the rate of 200 units per hour. The same machine center can process the second product at the rate of 300 units per hour. We have the throughput data for different production center. Throughput means how much we get out of the machine when we use the machine for an hour. We can now find out how many hours of different production center time required using the throughput data and output data. We are producing 10,000 units of a product P1. Machine center 1 can process 200 units per hour. It means we need 50 hours of machine center 1 to process these 10,000 units. If we perform similar computation, we get machine hours required and assembly hours required for different products. The table you see on the screen shows these values. Machine shop 101 takes 50 hours to process the first product, another 50 hours for processing the second product, 100 hours for the third products. During the month, the first machine center worked for 200 hours. Machine center 2 worked for 150 hours, machine center 3 worked for 125 hours. Assembly center 101 worked only for 25 hours because only one of the products P101 requires a facility. the production center is available for 200 hours for a month. That is 25 days, 8 hours per shift gives you 200 hours. What does it mean? M101 is working in full capacity, other machines have surplus capacity, idle capacity for A101 as the largest one. We are able to collect the cost data related to the production center for the month. We have a 3 cost pool for each of the production center: labor cost, power and fuel cost, and finally depreciation for the machines. We now need to charge these costs to the products. Here is our second challenge. How do you treat the idle capacity? Let us consider the assembly shop 101, where the idle capacity is the largest. Only product P10 requires assembly shop 101. The total cost of the center is that 3.56 million. Do we need to charge the entire cost to the product or only 1/8 of the total cost, that is 25 by 200? Here there is no right or wrong answer. We need to understand the consequence of charging the cost under 2 methods. If we charge the entire amount, you are working on the assumption that customer has to pay for all the costs incurred. This includes our idle time. If we charge only 1/8 on the other hand, you are working on the philosophy that we should not ask our customers to pay for our idle capacity or our inefficiency. Depending on your choice, the cost of the first product will differ. The difference depends on the level of idle time. In this case, the cost under option 1 will significantly higher than the option 2. Let us move forward with an assumption that customers have to pay for all our expenses, including the cost of idle capacity. We need to find out machine hour rate and assembly hour rate. Using these rates, we can charge the production center cost to the different product based on the utilization. Machine hour rate now depends on cost incurred for running the machine and also utilization of the machine. That is the reason for a very high machine hour rate for the production center A101. If cost remains same in the next period and if the machine utilization improves, the rate per hour will fall. If you feel it is unreasonable to charge the customer for your idle capacity, the total machine hour in the table will be 200 for all the machines and assembly centers. Consequently, the rate per hour will come down. Now, we need to charge the product using the machine hour rate and products demand on the machine and assembly center. P101 needs 50 hours of a machine center 101 and the cost per hour of the machine 101 is at 12,250. The total machine center 1 cost assigned to the product P101 is now 612,500. P101 does not require machine center 2 and hence no cost is loaded. It requires 50 hours of a machine 103 and the cost per hour is 72,000. The machine center cost assigned to the product 101 is at 3.6 million. Finally, the product is assembled in A102. It requires 100 hours. The cost per hour is at 23,846. The assembly cost now works out 2.38 million. The total machine center and assembly center cost assigned to P101 is now 10.16 million. If you perform similar computation, the cost assigned to P102 is 8.61 million and P103 is at 4.99 million. Let us take a break. You can use this break to work out how much production center cost you will charge to product P101, 102, 103 if you do not want to pass the cost of idle capacity to your customer. You will observe the production cost will significantly lower now.